Hello guys, this is Anurag Varma. Our capstone project is titled as Detection of DDoS Attacks using Machine Learning Techniques, a hybrid approach. This is the outline of the categories and components required for our project. Coming to the importance of the application, nowadays cloud computing is being used by many people because of its flexible services through a number of devices. And we also know that cloud computing provides its users to access the various cloud services and also enables them to use their data storage and the computational resources with a very low overhead, data overhead. But unfortunately, there exists a threat to it in the form of DDoS attacks. Basically, a DDoS attack works as follows. Many negotiated computers are used to target a network resource and a server, leading to flooding of messages and also transmitting malformed packets and connection requests, resulting in the denial of service of a individual user. Because of this, the user can get his or her work done properly, and the services which are being requested by the user would not be delivered properly. The aim of the project is to design a hybrid algorithm which consists a combination of different individual machine learning techniques to train a model which can be used to detect and classify the type of DDoS attacks that is being used by the hacker to attack the user, and also predict the attack with a higher level of accuracy than that of the each individual machine learning technique which is being used to form the hybrid model. Uh, Coming to the objectives of a project, the first one is to analyze the data and its parameters to check any redundancy in data values that might affect the prediction values and results. Then we try to remove all the empty and uncertainty values which results in a wrong prediction, and we'll be using different types of classifiers to compare the model accuracy of detecting the DDoS attacks and predicting them. Our main objective is to build a hybrid model which aims to provide a better and higher level of accuracy when compared to that of individual models. Coming to the existing system, nowadays there are many different approaches that are being used to counter DDoS attacks. One of those is called captcha puzzle, which offers a simple approach for attack mitigation. The user is asked to enter a set of characters or letters whenever required, but the system fails due to its ineffectiveness shown by recent studies in controlling the DDoS attacks. One of the example is that since the letters or characters that are required by the user to enter are already preset, we can use some machine learning algorithm to scan the text that is being asked and enter it automatically. We can see many extensions being used in different browsers, such as in Chrome and Internet Explorer. Other models are as follows. A digital signature for network flow investigation using meta-heuristic methods was created to investigate the abnormal traffic, which showed the improved accuracy in DDoS detection, but still the model failed to detect normal DDoS attacks. Another technique called 7, based on the adaptive and selective verification, which is mainly used to counter network layer DDoS attacks, is that this technique works on the concept of the notion of a state, but the application layer DDoS attacks do not possess a notion of state. The mechanism automatically fails against HTTP post flooding attack because the enormous amount of reflectors are used to send the payloads. Motivation. What motivated us to choose this kind of a title is that nowadays the cloud computing is being used by many people due to its many advantages, such as the ease of getting the data of a particular user without any hassle. And there are many situations that cloud computing works better than the regional conventional way of using the data. The main advantage of the cloud is that it flexibly scales to fulfill variable needs, and it gives the environment which scales up and downsizes quickly as indicated by the interest of an individual. So basically it needs incredible security from DDoS attack to handle various impacts of the attacks by the hacker. Denial of service assaults fall on the classification of basic assaults that bargain the accessibility of the system. These assaults have gotten refined and keep on developing at a quick pace. So, to identify and counter these assaults has become a difficult undertaking. Coming to the requirements, these are the basic specifications required by the user to identify and predict the DDoS attack using our hybrid approach. A minimum of i3 processor is required to process that many data entries, which is about more than 21 lakhs. And software requirements like Python and Jupyter Notebook IDE are required to run the code and to get the prediction of a DDoS attack. The process is quite simple. Firstly, we take the particular data set and import it to the Jupyter Notebook. Then later, by using the hybrid algorithm, we can obtain the accuracy of the prediction of DDoS attacks. Coming to our proposed system, we intend to use a machine learning approach to overcome all the shortcomings listed previously. In the proposed system, we have taken one data set which has 23 features, including source address, destination address, packet ID, packet size, etc., classifying the values based on the features, including source and destination address, using machine learning techniques like SVM, KNN, and naive Bayes in order to detect the DDoS attacks and calculating the model accuracies of the same. As told earlier, the hybrid model which is being designed by us includes these three machine learning techniques: SVM, KNN, and naive Bayes, and we intend to take the individual models and combine them to get a hybrid model eventually, and probably get a higher level of accuracy in predicting the DDoS attacks. In order to consider the worst case possible, we have used the following characteristics: sigmoid kernel for SVC and 5n neighbors for KNN, and the default is set for naive Bayes. The working and the classification block diagram will further be explained by my teammate Ashish Ravi.
As my friend previously explained about the proposed system design approach, now I am going to continue with the classification block diagram. As we can see here, server has a lot of data, and each data contains a several set of features which are known as source and destination IP, and it also has the port ID also. And in that we are going to inject several attack detection models, and which is mainly used by machine learning methods or algorithms. And each algorithm which we have included are SVM, which is known as support vector machines, and KNN, which is known as K nearest neighbors, and naive Bayes, and then random forest. Now continuing with that, now I am going to explain each and every individual component of our classification block diagram. Now as we can see, the working of SVM is mainly what it will do is that it finds a separating line which is called a hyperplane, which is in between the class of the data. This is a kind of algorithm that takes the data as an input and it gives a line which separates the different class as an output. As we can see here, we have the red ones and the blue ones. These two are separate support vectors, and it is being differentiated by a line which is called as optimal hyperplane. And this maximized margin is the difference between the distance of the first component of one support vector and the next component of the others. And now I'm going to continue with the K nearest neighbor working, and this algorithm is an easy to implement machine learning algorithm which can be used for classifications as well as the regression problems too. This algorithm assumes that similar things will exist in a near proximity, which also means that the similar things that are very close to each other, it will be bound to each other. As we can see here, we have got the red ones and the blue ones and green ones, and each has a separate individual items, and these are bound to each other, which are similar things. And red and blue and green, these three differentiate from each other. So this is the working of the KNN. And now we'll dive into the working of naive Bayes. And this naive Bayes algorithm is a probabilistic machine learning algorithm which is mainly used as a classifier technique. This is an algorithm which comes under supervised learning algorithms. The Bayes theorem tells us that the probability of an event occurring given the probability of an another event that has already been occurred. And now in this project we have implemented we have adapted the methodology which is known as blending. Basically, blending is a method in which we use different individual models to compute the initial prediction and then mixing those predictions in such a way that in order to get or achieve a better prediction, final prediction, which helps increase the accuracy of finding the respective attacks. Now I will dive into the project demonstration, which is our hybrid model approach. Basically, what we have to do is first we will find the respective data has been split into train data and test data. We have taken the train data as 80% and test data as 20%. Here, as we can see, the train data is been further been split into training set and the validation set. This method is known as blending ensembling technique. This training set contains the 80% of the train data and validation set contains the 20% of the train data. After splitting, then we will send the validation set to SVM, KNN and IBS, and these three algorithms use their individual methods and algorithms to make different predictions. And now each model provides two prediction sets, which are mainly validation prediction set and test prediction set. Hence, each validation prediction set from the three models are being concatenated into the validation input, and also likewise each test prediction set from the three models are concatenated to the test input. And now finally the newly obtained data, which is the validation input, will be trained with the random forest technique in order to create the hybrid model, and this model is actually used to make the final predictions on the test input in order to get the final predicted output, which in turn compared with the actual test data, which is our main 20% of data, and then the accuracy has been calculated. Now let me explain the code implementation of this project. And now here you are seeing the first chunk, which is importing the libraries and all. We have imported the pandas, MATLAB and NumPy, and here we have taken the sklearn, which is a machine learning algorithm importer, and we have taken the SVM matrix and neighbors, which are KNN, and neighbors and ensembling technique, which is blending, and also random forest, and import seaborn as SNS, which includes the imports the library which is known as heat map. Here we have imported the data. This is our data set, and we have imported that, and you can see what is there on the data set. This is the data which is included in it, and these columns are called the features. We have source address, destination address, packet ID, from node to node, etc. Like that, we have 28 columns which indicated the 28 features. And now, as they are the data set is vast, which is actually 21 lakhs, so what we have done is we have reduced the size to 3000, which we have taken as sample. This 3000 data set is using in our algorithm. Now, as we can see, the output of the 3000 algorithm, which includes equal distribution of the different types of attacks. And now here in this chunk, what we have done is we have just removed the redundancy items and also the empty values, so that in order to get the best accuracy possible. And here in this we have now taken we have training the model with the data set. Then this is the training algorithm, and next we are implemented the first model, which is SVM, which is support vector machine. And this SVM we have used the kernel sigma and gamma auto, and we have predicted the model, and it produces the output with the accuracy percentage of 70.16, which is good. And now the second model which we have taken is the KNN, which is k nearest neighbors, and here we have taken the neighbors, which is equal to 5, and now we have trained this model, and this model got the output with the accuracy score of 77.80, which is greater than the previous one. And next we have used the Gaussian naive algorithm, and we have trained the model, this one too, with the dataset, and then we got the accuracy score of 76.5, which is also good. Now what we have done is, this is our hybrid model, and we have used the blending technique right starting. So blending technique, which includes the separation of train data into separate training set and validation set. Here we can see the training set and validation set. Training set is 8% and validation set is 20%. And now we can see, here you can see the what is the training set. The total is 3000, right? So training set, which is 80% of 3000, is 1920, and then validation set 20% is, which is 480. And now first blending, which includes the three models. We have included three models in our hybrid model. These three models, which are SVM, first one is SVM, and we have got the validation prediction and the test prediction, and the second model, which is the k nearest neighbors, and we have got the validation prediction and test prediction, and third model, which is Gaussian neighbors, we have got the validation and test prediction. What we have done is, since we got the three validation predictions from the three models and the test prediction from the three models, we have concatenated the main validation prediction from the one which is this is SVM, and this is KNN, and 3 which is Gaussian IMS. We have concatenated the three validation predictions into one validation input, and then we have concatenated the three test predictions into one test input. Now we have predicted the we have trained the model in such a way that we have included the input as the validation input. See, the validation input has been declared in order to train the data, and we have used a random forest classifier for that. And here after importing this, we got the accuracy score of 80.16, which is greater than the previous three models, as the SVM produces the 70% and KNN produced 77% and Gaussian IMS produced 76.5. And this hybrid model approach, we have got the percentage of 80.16, which is greater than the previous three. So that's why we have implemented this model in order to get the better accuracy, in order to detect the DDoS attacks more accurately. And now next part, results and discussion, will be discussed by my friend Sandeep.
As said by my friends, now I am taking the lead for results and discussion, for which we created a hybrid model is used for making analysis of DDoS attack in the earlier stages and earlier stages on the cloud computing environment, and thereby we can also calculate the highest accuracy ever in this algorithm of hybrid, which we have done. Now we can also take some of the examples, such as in figure 1 we have shown series 1 indicates the first series of testing, and series 2 indicates the series 2, and series 3 indicates the second and third testing of each model respectively. There are 4 models: SVM, KNN, naive Bayes and hybrid model, among the which shows the highest accuracy was our hybrid model than others, whereas the accuracy levels in the hybrid models are very highest when compared to the other, and actually it can also predict the DDoS attack very in the earlier stages in hybrid algorithm when compared to the others. They will also detect, but they can just detect it not in the early stages, but somewhat like in the middle, or if you go into the half of the part, then they detect it. Now coming to the conclusion, we have created this project so that it will be useful to everyone to use the hybrid algorithm on the combination of all the machine learning technique use, and so that we can train a model which can be used to detect and classify the type of DDoS attack which is attacked on our attack, which type of attack it got attacked, and with greater accuracy of individual machine learning technique used in the hybrid model. This hybrid model will provide more level of accuracy prediction of DDoS attacks. It is more effective than the other models individually, like SVM, KNN and naive Bayes. This concept is used to predict early predictions of DDoS by machine learning technique use. The effect of Daniel of services will be detected by using this hybrid algorithm. Now we also wanted to make some of the future developments, such as future implementation will focus on mainly on implementing 100% accuracy of hybrid model, and we want to demonstrate an real-time project so that it would be useful and can be used by so many others for their future purposes, and then we also wanted to create a web page so that we can know how much of the DDoS attack level and what is the type of the attack got involved in it, and we are just working on it, and we would develop it in a good form, and we are hoping for the best. And now coming to the references, we took so many references, including a survey on detecting application layer DDoS using big data technologies. It's a journal of emerging technologies and innovative research which got published in 2019 by Paul, Jyoti Grover and some of the other fellow mates. They gave us some of the ideas regarding this project, and they also developed some techniques which could can take as our guide, and we could self guide ourselves, and we could work on it easily. And then we went to the some of the journals, journals such as critical analysis of DDoS and emerging security threat over IoT networks, which we have also worked on IoT networks IoT networks, and we worked on IoT networks, like how much DDoS attack levels and threats we can find in each and every network, and how could we get corrected from this. This could be a big challenge to each and every thing, and that's why we developed an hybrid algorithm which could provide an more accuracy when compared to the others. It is now we can say that we have completed our project in such a way that the project includes most of the hybrid algorithm concepts, and it can make a breakthrough to each and every accuracy levels when compared to the others. Thank you.